All right, so what I bring off to the side here is, so we look at part A. It says if we randomly select 3 men, what are the mean and the standard deviation of the sum of their weights? So this is thinking about combining distributions, but now we have 3 of them. So it's kind of like we're doing x plus y plus z. And what I've drawn off to the side here, because the weight of adult men is approximately normal, I drew 3 different pictures of a normal distribution, but really it's the same distribution that the 3 men are being selected from. So sometimes it's like different distributions completely that are being combined. This is kind of a way for us to think about they're coming from the same one. Each distribution is approximately normal with the labels here, mean of 190, standard deviation of 30. But we can think about them as being separate x, y, and z for the 3 men that we're randomly choosing. So let's start with finding the mean. So now, instead of just x plus y, we have a third one on here. Well, we're just going to add all 3 of the means together. And the means are not different from one another. Sometimes they are. In this case, it's just all the same value of 190. So the mean for the first, plus the mean for the second, and then the mean for the third. All together, that's going to give us an overall mean of 570 pounds for the sum of their weights. All right, let's look now at the standard deviation. So the standard deviation of the sum of x, y, and z. Well, we know again that one does not simply add standard deviations, but we can add the variances. So let's take the standard deviation of 30. We're going to turn it into a variance for all 3. So we have 30 squared. Add that to itself 3 times, and then we'll take the square root of all of it. And this is going to give us 51.96 pounds. All right, now that information there that we just calculated for part A, that is going to help us with this elevator scenario in part B. So we have this elevator, it's in a small apartment building, and it has a maximum weight capacity of 700 pounds. So we're going to think back to this scenario with 3 randomly selected adult men. If they all together get on the elevator, we want to find the probability that the maximum capacity, that they exceed the maximum capacity. In other words, the sum of their weights is greater than 700 pounds. So what we're going to think about now here, starting off with a picture, is a normal distribution representing the combined distributions that we were thinking about in the last part of the problem, representing the sum of the 3 men's weights. So we found our new mean, our combined mean was 570. Our new standard deviation was 51.96. And then the value in question is this cutoff for the maximum capacity of 700. So that's going to be somewhere over here to the right. And we're interested in finding the probability that they exceed 700 pounds, all 3 of them. And so exceed means we want to find the probability here. Our shading is to the right. All right, now from here, once you have your picture drawn and labeled, you have 2 options for how to finish out your normal calculation. You could find a z-score. So that would look like this. We're going to do the value, 700, minus the mean divided by the standard deviation. And this should give us a z-score of 2.51. And then we could go to Table A. By the way, you will have a Table A for our Chapter 6 test. So let's find the side where we have our positive z-scores. And I'm just going to find here 2.51. So I can see that the area listed on the table is 0.994. It seems like a lot. It's a huge amount. Remember that the area off the table is always shading to the left. And if you forget what side it is, just look at the top of your Table A. It'll show you a little picture, and it'll indicate where the shading is. So it's 0.994 to the left, and so anytime we have our shading on the right, this is where we're going to go ahead and subtract that from 1 to get the part that we're actually interested in. And it turns out it's a really, really small probability. It's actually an extremely small likelihood that the 3 men would exceed the maximum capacity. Less than 1% chance of it happening. It's actually 0.6%. So I would say I would be very surprised if they exceeded the maximum capacity, because it's really not likely for it to happen. If we ended up getting a probability that it maybe happens like 25% of the time, well then I wouldn't be as surprised if it happened, because 25% is like way more than 0.6%. All right, now here's the other option. I'm just going to switch to a different color here to make this stand out. You don't have to do it with a Z-score. You could go to normal CDF on your calculator. Now, if you use the normal CDF, you're still going to draw the picture, draw and label your picture, but then you could just move forward to this part. So remember, to get to our distributions menu on our calculator, we're going to press second bar. Normal CDF, it's right there near the top. And the inputs here, we're going to start by listing out the lower, basically the lower bound and the upper bound for the region that is shaded in. And this is why I still want you to do a picture, because it's very easy to just look at your picture and know what's the lower and what's the upper. As we also just talked about, we're also going to label those, literally label them with the words lower, upper. All right, and then we're going to input the mean. You can write the word mean, or you can use the symbol. And then we're going to input our standard deviation. So if you enter that into your calculator, you'll see that you get the same final answer of 0.006. If your calculator gives you the prompts for the inputs, that's super nice. However, if not, that's okay. You do just have to remember the order that you're going to type the numbers in. It's still going to look like this. We should still get the same answer.